Okay, this is Arizona 236, pH and resistivity. pH and resistivity is run on plus number 8 material. If the material is wet and needs to be dried, you cannot dry it at a temperature that exceeds 140 degrees Fahrenheit. Once it's dried, we're going to need to obtain 2,000 grams of material, approximately 2,000 grams. We do that by splitting. And we have here approximately 2,000 grams. We're going to sieve that over the number 8 sieve. I have some clods in here. You need to make sure you break up all those clods. You want all the past number 8 material out of the way. Okay, so now I've sieved my material over the number 8 sieve. The test is run on minus number 8 material, not the plus number 8, and minus number 8 material. I need 1,500 grams, approximately 1,500 grams for my resistivity, and approximately 50 grams for my pH sample. So I have to make sure I have enough for those. The resistivity has to be split. So I got my sample. Okay, so I've got my sample here. I need to use my splitter to split that down to approximately 1,500 grams. You have to use this induction device, the one that you're going to induce your sample into, to split it. Make sure your pan's under there. Pour it through the center of the slot. Continue splitting it until you get approximately 1,500 grams for your resistivity. I have 1424. To me, that's not approximately good enough, so I need to add a little bit more material. Okay, I have 1503, which is good. This is for my resistivity. I can go ahead and set this off to the side for right now. Now I need to obtain my pH sample. The pH is approximately 50 grams, and for it, you can just measure your 50 grams out. You want it to be pretty close to 50 grams. Not much over 50 grams, because we're using a 100 milliliter beaker, and you have to add the same amount of water. So if you get it too much, you'd overflow your beaker. .5 grams of material, I need to add the same amount of distilled water for my moisture. So 50.5. Has to be distilled water. So I have this pipette. I overfilled it a little bit, so I'm going to use the pipette to get it down to exactly 50.5. I'm good. Now I can add these two together. Stir it with my glass rod here. Make sure you stir it good. Get all that material soaking, get all those fines suspended. Now we're going to let it set for 1 hour. And that's it. Okay, for the pH, I just added my water with my sample, mix it thoroughly. I'm going to let it set for 1 hour. In that hour, every 8 to 10 minutes, I'll come back and stir this. Now, sometime in that hour, I need to standardize my meter. To standardize the meter, I'm going to use buffer solution. I have to use the number 7. And then I use either the number 10 or the number 4. Which ones that I use? The ones that I use is dependent on what range I think my pH is going to fall between. If I think it's going to fall between 7 and 10, then I would use the 7 and 10. If I think it's going to fall between the 7 and 4, then I would use the 7 and 4. For the Phoenix area, most of ours fall between 7 and 10, so I would use 7 and 10. The pH buffer solution has to be within 2 degrees Fahrenheit of my sample. So I would check both of those, make sure they're within 2 degrees Fahrenheit. I'm going to standardize my meter per the manufacturer's instructions. Whatever it says, each meter is slightly different. So what I would do is go ahead and get my, standardize it using the 7 buffer solution. Do hit whatever buttons it calls for. Clean it off in between different solutions. I would use number 10, push the correct button per the manufacturer's instructions. Now it is standardized. I'm ready to go. I can wait until the end of the hour. Then I can continue my test. Okay, it's been an hour. This is my final stirring. Again, I want to make sure I stir it thoroughly. I want to get those fines into suspension above the coarser particles. My meter has been standardized and ready to go. Take my probe, place it into the slurry mixture, but not into the coarser particles. I let it set, push the correct button, let it set until the meter stabilizes. Now that may take up to 5 minutes to let it stabilize. When it stabilizes, then I'm going to read my pH from the meter, directly from the meter. Most meters, this meter goes to the nearest 0.01 ohms. You need to record that to the nearest 0.1 ohms. This is reading 8.53, which is around 8.5 ohms. Okay, this is the resistivity part of 236. I have my approximately 1,500 grams of minus number 8 material. I have to add 200 milliliters of distilled water for my first trial. Has to be mixed in there throughout the sample thoroughly. Once it's well mixed, then I'm going to place it into my soil box. One continuous lift. Just make sure you're going to have to slightly press it down with your fingers. Make sure you get into each corner and you fill all voids. Once you have it filled, you can level it off with your straight edge. Make sure your connection points on the side are clean. I'm going to set it, connect my resistivity meter. One lead to one side, the other lead to the other side. Now I'm going to take my test. There are different meters. The procedure to use them is according to the manufacturer's instructions. I'm reading 2100 ohms right now. When you record this, you record it to the nearest 10 ohms. So that'd be 2100 ohms. That's my first trial, my first reading. All this material has to be returned to my mixing bowl. And then my soil box has to be rinsed out with distilled water. Make sure you get it completely clean, okay? For my second trial, I need to add 50 milliliters of distilled water. Again, make sure that it's spread throughout the sample. Once I have it thoroughly mixed, I put it back into my soil box. Do it the same way I did it on my first trial. Again, once you have it filled, level it off with your straight edge. Make sure your ends are clean. Again, hook up your meter. And then take your second reading. I'm reading 770 ohms. Again, report that to the nearest 10 ohms. Now, I would continue adding 50 milliliters of water, continue my trials, adding 50 milliliters of water each time. What's going to happen is my readings are going to continue to drop, and then finally they're going to go back up. The lowest reading before an increase is the reading I use for my minimum resistivity. Then per the procedure, that lowest reading is multiplied by the soil box factor, and that gives you your minimum resistivity, and you report that to the nearest whole number.
Please be sure to review all of the materials available in your Soils and Aggregate Technician Certification Workbook.